Hi guys, welcome to my number sense series. In this video, we're going to talk about addition and subtraction. So with addition and subtraction, there's a few main ideas, but they all converge into the most important idea. And that idea is that it's a lot easier to add and subtract numbers when we have zeros in the equation. For example, take a look at this, 358 plus 400 versus 358 plus 274. You'll notice that it's way easier to do this than this. Because in this problem, we're going to have to carry multiple times. In number sense, we really want to avoid carrying because having to remember if that extra one is there or not is a super easy way. So we would like to transform our questions to look something like this, where the addition is really easy. But the question is, how can we do that? The answer is with these three properties. So these three properties are probably something that you already understand and use intuitively, but I think it's nice to just put names to the faces. So for example, the associative property is kind of like regrouping. It says that we can add a plus b first or b plus c first, and the order of addition is going to stay the same. Now the commutative property is kind of like saying we can swap the order of addition, but I think the most important one is the distributive property, which allows us to distribute and refactor these expressions. And you're going to notice that I used a double arrow here, pointing in both directions, because we're going to have to use this identity both ways in order to simplify our calculations. For example, take a look at this question. 197 plus 278. If we just do this using like the column method, we're going to run into a lot of carrying. But we can notice that 197 is actually really close to 200 already. It just needs like a 3 to get to 200. So we can basically just get 3 from 278. So what we can do is kind of mentally write this as 197 plus 3 plus 275. Because we've decomposed this 278 into 3 and 275. And now we can regroup this to write 200 plus 275, which is of course equal to 475. And if you're not interested in thinking this rigorously, you can simply think of it as, oh, I can add 3 to this and subtract 3 from this, so it's 200 and 275, which is very easy. Now, you can pause if you'd like to try this one on your own. So this problem, the idea is really similar to this. But we have 2,995, which you can notice is really close to 3,000. And it just needs that extra 5. So we can get that extra 5 from this number. So we're, once again, going to decompose our second number and write this as 2,995 plus 5 plus 5,433. And once again, this is just 3,000 plus 5,433. That is very easy. It's obviously just 8,433. Now with subtraction, the idea is pretty similar. We would really like if we were actually subtracting something nice like 300 instead of 292. But we can notice that 292 is really close to being 300. It's just missing an 8. So what we can do is rewrite 292 as 300 minus 8. So this becomes 488 minus parentheses 300 minus 8. And now, in order to get rid of these parentheses, we're going to use the distributive property. Now, what this does, because we're just distributing in this negative, is it turns this into a minus 300 and this into a plus 8. So it's 488 minus 300 plus 8. And now we can kind of regroup these. 488 plus 8 is just 496. Minus 300 equals 196. Okay. Now, instead of doing all this, in your head, you can kind of think of it as, oh, I'm going to subtract 300 first, but I kind of over-subtracted because I only wanted to subtract 292, so I'm going to add back a plus 8 to make it like even again. You can kind of do that in your head as well. Now, you can pause if you'd like to try this one on your own. So, with this question, it's again a similar idea, but we're subtracting 1,993, which is, we can notice, really close to 2,000. So we can write this as 2026 minus parentheses 2,000 minus 7. And then again, using the distributive property to get rid of these parentheses, we have 2026 minus 2,000 plus 7, which we can group these two and add them, is 2,033 minus 2,000, which is simply 33. And again, you can kind of think of it as subtracting 2,000 and then just adding 7 to kind of compensate for your over subtraction, if you'd like to do it that way. Now these, we're not going to explicitly change any of the numbers, but we are going to change the order in which we do the operations. For example, Here, if we do this, and then this, we're going to have some not very nice numbers pop up. But we can notice that we're actually adding a 1, and we're also adding a 9 here. And these two, when combined, we get a nice number. We get 90, actually. And numbers that end in 0 are, again, easier to do operations with. So this is a small improvement, but every little improvement matters in number sense, especially with this 10-minute time limit that's so restricting. So we can add first and then subtract if you want to think about it like that. So we're going to rewrite this as 61 plus 29 minus 44 minus 26. In your head, you don't really have to do this, but just know what you're adding and subtracting. So just keep your signs straight. So 61 plus 29 is 90. Minus 44 minus 26, we can just think of as subtracting those two numbers added together. And we can formalize this using the distributive property in reverse. But 44 plus 26 is 70. So our answer is just going to come out to 20. Now it's a similar idea with this one. You can pause if you'd like to take a try. So once again, we're going to group these numbers such that we have some nice subtraction going on with the units digits. So we notice that 3 and 7 are going to make a 0, 8 and 2 are going to make a 0. So we can group these two. Once we add these together, we get 80. And we're just going to subtract, parentheses, 28 plus 32, which is just 60. 80 minus 60 equals 20. And that's it. So 20 for both of these. Now, this last kind of problem is what I would say is the most challenging kind of problem, because we're going to have to here recognize when we can use the distributive property in reverse. If we actually did 7 times 96, there's a pretty high probability that we make an error while trying to do this in your head. So what we can do instead is recognize that this 96 is actually kind of close to 100. It would be really, really nice if we were actually multiplying by 100, but we're not. But these questions are specially made so that we can make these happen. We can say 28 is actually 7 times 4. So it's like 7 times 4 plus 7 times 96. And this is just 96 sevens plus 4 sevens, which is 96 plus 4 sevens. So this is just like using the distributive property in reverse, going from AB plus AC to A times the B plus C. We're going to factor out this 7, basically. It's 7 times 4 plus 96. And 4 plus 96 we know is just 100, so it's just 7 times 100, which is easily 700. This next problem is a similar idea. You can pause if you'd like to try this one. And with this one, we're once again going to notice that we can actually decompose 121 into 11 times 11. And now, we're going to, again, use the distributive property in reverse. So going from AB plus AC to A times B plus C, we can think of it as 11 11s plus 189 11s. So in total, it's going to be 11 times 11 plus 189. And 11 plus 189, this evaluates to simply 200. So it's actually 11 times 200, and this is very, very easy. It's 2200. So these are the 4 main kinds of addition, subtraction, and a little bit of multiplication problems that we're going to find on the number sense test. These are pretty common, especially near the start. It's important that we know how to do these quickly and efficiently and without making mistakes, so we can kind of build up our confidence and kind of speed through the rest of the test. So I'm going to leave some problems in the comments. You can try them if you'd like, just for some extra practice. Thank you guys for watching, and I'll see you in the next one.